Hello, this is my presentation for Chemistry 2 at Doane University. Today we are doing ferrofluid. So I've already set this up and tried it out. Wasn't super successful, but I'll show you what happened and talk about why it wasn't successful, but what should have happened. So here is my solution, which it's yellow because ink toner was not an option, so I tried to find something similar. Got ink for the printer, which was yellow, and obviously that wasn't the right thing. But my magnet, as you can see, is doing nothing. So obviously the fact that I didn't use ink toner was probably the main issue in this and why it didn't work. Also, my magnet is not as strong as the rare earth magnets that were suggested, so that was also a factor. But what we should have seen was a ferrofluid, which is a liquid magnet essentially. It's made up of vegetable oil, ink toner, and then you use a rare earth magnet just to kind of move it around. And what should happen is as you bring that magnet closer to it, it should form spikes. There is a magnetic field with the liquid, but the pull from the rare earth magnet would be strong enough to break the surface tension and the fluid weight, which are the things that are holding it in place. Because generally, this fluid would not flow much. So essentially that's what's happening. We have them opposite poles because it is forming the spikes. For example, if you look up this image, you can see how if you have permanent magnets below it, on the ones with the magnets, it has spikes going up. That's because it's moving away from that pole of the magnet. So that's why that's happening. Applicably, this fluid does have some purposes. There's been a couple studies done about it. Because of ferrofluid's tendency to not flow and to have such a strong reaction to magnets, it's actually used for some seals. Mainly because if you put the fluid there with the magnet, it's not going anywhere. Another thought process that people have been looking at, there was actually some studies done on this recently. I don't have the name right here, but I will hunt for it later. He did some testing on it to see how it would do based on movement, magnets, how strong this magnetic force was. And they found it to be quite strong. So applicably, it might be able to take the place of certain electric fields. The advantage of this would be that a magnetic field does not throw off sparks like an electric field would. So we wouldn't have the same risk that we do with electric fields. So yeah, those are the main benefits of a ferrofluid. Again, didn't work out for me. Biggest flaws were no ink toner, as well as probably a higher concentration of vegetable oil than it should have been, and then a weaker magnet than a rare earth magnet, which I had ordered and did not come in time. So I just settled for a weaker fridge magnet. But I think this is definitely something I'd like to try again and see if I can get working, because from all the videos and photos that I see, it's a really, really cool experiment that could potentially have a lot of impact on technology and engineering and even just physics to see how this all works. So hope you enjoyed. Sorry for an unsuccessful experiment today, but I hope we have all learned something new about ferrofluid.